Okay, so if you're watching this, you probably have watched my previous video, and I promised to explain how exactly I tidied up the data from the Met Office into a nice clean format. Because if you tried yourself and went onto the website, hopefully you'd been able to navigate your way to some data which looks like this. So this is the raw output which is stored on their website. And just trying to read this in directly to R, we'll see immediately there's a few problems. This is a very common format for climate data, as I'm sure people who have worked with climate data before will recognize. We don't have a nice consistent table of data. We've got some metadata at the top. We have headers here, but then we also have metadata about the headers beneath them. I can also see an issue here where slightly unusual choice for recording missing values, 3 dashes. And if I scroll down, you can see here there's things saying, okay, that could have data marked with a hash. That could be a problem. If I go all the way to the bottom of the data and look for the current year, I can also see there's a bit of weird formatting going on here where there's some stars next to provisional values as well. So there's quite a few potential challenges in this data set, which I'm going to have to overcome when reading it in directly. And yes, I could take this to Excel and manually work through a lot of this, but instead I'm going to see if it's fun to try and work through this in R instead. So the first thing I'm going to do, which is quite a nice thing to do, is just because it's got the URL and it's loaded like this, I can load it into R directly without having to download it onto my computer. I could just read it in from the website if I use the URL function and just paste the URL into there. So the function I'm going to use to read in the data, I'm very much not going to be using the import dataset menus. This is beyond their capabilities. Because the main body of the data is tab separated, and it's in a TXT format, I'm going to use read.table as the function to bring this in. So I could just run this line here, and okay, I immediately get an error saying, okay, line 1 did not have 13 elements. I'm going to need to do some thinking about the exact format of that data. So let me scroll back to that particular window. The first thing I want to do is, okay, I want to skip all of this stuff up here. So I'm going to need to use the skip argument, and I'm going to want to skip, I guess, the header. So I'm going to say 1, 2, 3, 4, 5. I'm going to skip 5 rows, but I'm also going to tell it's a header. So if I put header equals true, then that should hopefully skip the right number of rows. I might need 6. Let me double check. So if I put in skip equals 5, okay, that's getting a little bit warmer. I'm also going to put in header equals true. Same problem. But I'm also at this point going to remember I have the kind of nice argument, which is fill. So if I put fill equals true, it will force the data to be read in and not complain here that the number of rows aren't always, or the number of columns, sorry, the number of elements per row is not always the same. If I put in fill, this should solve a few of my problems as well. Let's see, okay, now we're getting warmer. So here, I've skipped 5 rows, I've started on the 6th row, which is now my header row. And you can see this is now looking a bit better because the header row is mapping up to the header row from the data. I've got YYYY, MM, Tmax, Tmin, AF, rain, sun. This is good. So that magic trick of fill here, the problem was because we don't have in this second row, you see there's nothing underneath rain and nothing underneath sun. That's not actually true because it's got misaligned here, as you can see, because there was actually nothing under YYYY and nothing under M. So let's put the fill at the end rather than the beginning. I guess the nice news here for us anyway is I don't really care about this first row of the data anyway, so I'm going to be skipping that in a minute. But before I think about doing any of the functions, within read.table, I want to deal with these missing values because there's a nice argument here where I can say na.strings, and it's not dot, sorry, it's dash, 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 getting my Morse code mixed up. So here, This will now hopefully turn these dashes into missing values. Let's see. There we go. So now this is recognizing those dashes as NA values. So I think at this point I can read this in, and then I'll need to keep doing some more manipulations, because remember there's other issues in this data as well with those stars, possibly some hashes, and we've got this first row to deal with. But I'm going to read this in as raw, and I've then got an actual data frame to play with, which at the moment has 2023 observations. So I'm also at this point probably going to read in Doppler. I'm probably going to need to use that, because I think the first step that I want to take from here is to just get rid of that first row. I think I want every other row for the moment. So I'm going to use a kind of underrated function, doesn't get used that much. I'm going to use slice, and use slice of -1. So slice is a way of setting rows based on their position. So here this will just get rid of the first row of data. It will remove number 1. So as you can see, those horrible columns which were misaligned, or sort of column labels which were misaligned, don't have to worry about that. I've just moved straight in to my actual data set here. Okay, so let me just scroll through, and I want to see what's going on, because I remember from before, right at the end of my data, and maybe I need to open it up here rather than anywhere else. I remember if I go to the very, very end, yeah, there was actually an extra column where there was provisional. So I think I want to get rid of here. This was again part of the fill, because this wasn't a labeled column. It's moved this into a new row and then filled in stuff after it. So I can very much get rid of these rows. They're not telling me anything. The stars are also doing the same job. So I'm going to say get rid of the provisional years completely. So when I do my filter, I'm going to say I only want real data. I don't want this provisional data. So I want year not equal to 2020. And I want year not equal to provisional. Again, make sure that's an and rather than an or. Also, because this is still being treated as a character, I think I'm going to have to put 2020 in quotation marks. So now, when I scroll to the end, and I won't be able to actually see it here, but I can see from the output, I've reduced it down to 2004 rows. Previously here, this would have taken it down to 2022, and this has taken it down to 2004. So I'm fairly comfortable with this. I am going to just save it into an object and check this just to be sure before I move on to any further steps. So let me scroll to the bottom. Yep, that was good. It now ends in 2019. Okay, so what else do I need to do? If I scroll up a little bit, I do remember seeing there are definitely some stars, and there might be some hashes as well. Although the hashes are in the sun column, if I recall the metadata correctly, and I don't really care about the sun column, so I might forget about that for now. But here, I definitely want to do something about those stars. I think from scrolling through before, they appear in a couple of other places as well. Yeah, there. Here, maybe I do care about these provisional values. When they're in the middle of my data, I'm going to want to keep these for this particular format. So I am going to need to remove those stars, because if I try to convert this into a number at the moment, I will get very confused and say this is a missing value. It won't interpret this as, if I find a number, I should have gone up then. Yeah, it will interpret this as a missing value if I try and treat this as a number rather than 13.2. So this is where I am going to use the string R library, which is a nice library for dealing with a little bit of text manipulation. This is getting into the world of, when we're using regular expressions, which can be a little bit tricky to work with. And particularly whoever put the star into this format really hates people who have to work with this data, because the star is kind of a special protected character. So if we try and do something simple to get rid of those stars, it's not going to work because the star means something special in this world of text manipulation. So I would like to get rid of the stars everywhere in this data. There's no valid place for me where I want a star. So I'm going to use the mutate all function to modify all of the columns in my data. So I'm going to use mutate all. There's these nice sort of add-ons to mutate and filter, which you can mutate at or mutate all, and filter all or filter at to select more than one column at a time, or in this case, all of your data at one time. So if you're doing something here, you need to use a little tilde to say, I'm doing this everywhere across all of my columns, and I would like to replace a star with nothing. So within the stringr function, there's lots of, or stringr library, there's lots of these little functions we can use for manipulating strings. So I am going to use str remove to get rid of a particular pattern, a particular bit which is in my strings. And within this mutate all, I need to give it a dot to kind of say all columns, I want to do the same thing. And then so this is the string argument. I'm saying the dot is representing here that all of the strings, everything in my data. And then the pattern that I want to get rid of is a star. If I run this now, though, it will not give me anything nice at all. The star is a special character, and this just scares it a lot. So the way to deal with this is if I use square brackets around it, this sort of says, okay, I'm actually looking for a star. I'm not treating star as a special regular expression character. So now when I run this, I don't see an error. And let me go to my data. It doesn't seem to have completely destroyed it at the top, but the key part is at the bottom. I should have noted down exactly where the star was, but if you can see, it looks like I have managed to get rid of those stars. So using that square bracket is really a key thing to know how to do if you have to do little fiddly bits of data manipulation like this. Okay, final step is, as I've mentioned, because of the way it read in the data, where it was all a bit strange with the formatting, it's still treating everything as a character. So I'm going to use another mutate all to convert everything to be a number. In this data, it's, I think, valid to say all of these could be treated as numeric columns. Doing this as well will hopefully reveal if I've missed anything at this point, because if I try and convert everything into a number and unexpected things happen, or I get some warning messages, that probably means I've missed something. So I might have missed a hash, or I might have missed something which I didn't pick up earlier. So I am going to again use a tilde, and I'm going to use as.numeric, and then again I need the dot to say I would like to do this for all of my data. Hasn't shouted at me, hasn't given me an error. This is nice. Let me head over to my data. And yeah, I think this could be a winner. If I now have a look at a summary of this new tidy data set, and if I get some nice summary stats, this is good times for me. The thing I might want to check is, okay, is this really a missing value in tmin? Was there a missing value there when I first read this in, or is this something that I've done by the way that I've manipulated it here? With the sun, I remember there's a whole bunch of missing values in that column, so I'm not super worried there. So let me identify where that missing value is. So if I do a quick filter here, and I want to know where is.na tmin. So this will filter out the data set, and is.na will say, okay, which one is a missing value? So I am looking for December 1860. So let me look in my original input here, go back to the source, and hopefully I will see something which should be a missing value if I head to December 1860. Yeah, we can see in December 1860, this looks like it was a valid missing value. Let me just double check way back in the source, even before I read it in. because perhaps there was something in that first importation step. It's always good to be very careful, but no, yeah, looks like December 1860, nothing at all, few. That's not a result of me messing up, that's a result of there being a missing value in the data. So at this point, I'm happy with what I've done. I've got my tidy data set. I've checked that. I'm pretty confident now that this is the real data. I've not corrupted it by doing these steps. And I'm good to go ahead and feed this in to my main process, which is actually building the warming stripes plots. But you can see in general, data is not always there in immediately the nicest format that we'd all like it to be in. So getting familiar with a lot of these fiddly steps of, okay, what are the arguments within the read functions, depending on different formats of data, with the skip and the header and the fill and the na.strings, they can be very useful, as can knowing some of these little tricks with stringr and mutate all to try to understand better what we would need to do under different circumstances. Everything I've done here, it's not super generalizable, it's specific to this format. If you work a lot with climate data, it's a very common format. If you work with other forms of data, there might be other specific problems in there. And the more comfortable you get with learning more packages, learning more functions within those packages, and particularly within Dipler and stringr, this will really help you tidy up that data so that you don't end up making mistakes in your analysis, and to really speed up this process of actually getting from the data to something that we want to do.